Hello everyone, my name is Kunal and I am your mathematics tutor and today is our lecture number 8 of indefinite integration and today we are gonna learn something like more trigonometric integration cases and the reduction formula of like tan to the power nx we actually gonna learn today and do some practice problem. So let us begin our lecture with some more type. uh, तो अब तक हमने क्या क्या पढ़ा एक बार मैं रिकॉल करा देता हूँ. तो हमने इंटीग्रेशन में अभी तक लाइक बेसिक इंटीग्रेशन इंडिफरेंट इंटीग्रेशन के डेफिनेशन वगैरह प्रॉपर्टीज वगैरह बेसिक फॉर्मूले एंड हाउ टू अप्रोच द इंटीग्रल के 4 टेक्निक हमने पढ़ रखे हैं. द सब्स्टिट्यूशन वन, बाय पार्ट्स वन, पार्शियल फ्रैक्शन एंड सम मिसलेनियस वन. एंड देन आफ्टर हमने सम स्टैंडर्ड बेसिक अलजेब्राइक इंटीग्रल के बारे में देखा. एंड देन कुछ अलजेब्रिक इंटीग्रेशन के केसेस देखे, राइट. कुछ इंपॉर्टेंट ट्रिग्नोमेट्रिक सब्स्टिट्यूशन देखा. एंड देन फ्रॉम यस्टरडे लेक्चर, कल की लेक्चर से हमने क्या स्टार्ट करी थी. वी स्टार्टेड लाइक ट्रिग्नोमेट्रिक इंटीग्रेशन के कुछ स्पेशल टाइप, तो वो हमने स्टार्ट करा था. सो टुडे वी कंटिन्यू द सेम थिंग and then reach to the reduction formula and certain like thing. So let us begin our lecture number 8. Okay, close that window first. Okay, so today we gonna start like कल की lecture में हमने कुछ types देखी थी. Like type A, मैं एक बार recall कर देता हूँ. Like type A look like integral of dx A sin x plus B cos x plus C type, जिसमें हम लोग sin x को क्या लिखते थे. We write sin x as 2 tan x by 2, 1 plus tan square x by 2, and then substitute tan x by 2 as t. And then we write cos x as 1 minus tan square x by 2 by 1 plus tan square x by 2. Then we move to the type is something and plus d. So how we approach this kind of problem. तो हमने approach इसकी ये थी कि we just divide this denominator by cos square x and numerator by cos square x. हम divide कर देते हैं. Divide numerator and denominator by cos square x term, and then we form something like tan x and sec square x, and then we proceed on, right. So this is our type B, and our type C look like something. Type C जो हमारा था, it's something look like A sin x plus B cos x plus C divided by D sin x plus E cos x plus F. और हमने एक इसमें स्पेशल केस भी देखा था विथ C and F will be 0. सो उसकी शॉर्ट ट्रिक भी बताई थी मैंने. और जेई मेंस इट इज इम्पोर्टेंट, सो उसकी सारे शॉर्ट ट्रिक मैंने बता रखे हैं. सो इफ यू गोना वॉच, if you wanna look into that, so go to my lecture number 7. So today we are gonna move some and look some more type, which is our type D. So let's start with a new type. So this type, this kind of integrand is important for JEE many purpose, because JEE advanced में इतनी आसान क्वेश्चन नहीं आती हैं. So let's move on to that. So our type 4 look like if our integrand look like something sine to the power mx, cos to the power nx, and then sine to the power mx, cos to the power nx, where m and n belongs to the whole number, and again where m and n belongs to the whole number, that means 0 and positive integer, right. So this is our integral look like sin to the power mx. तो इसकी रूल्स क्या है इसको सॉल्व करने के. So rules for solving such an integrand is rules for solving such an integrand is इसके rules क्या हैं? तो इसके first rules होते हैं like ऐसा. So it's rule like कि if one of the exponent is odd, then put the other form will be uh, t. Yeah, substitute it to t. And other form like I'm saying कि other form like sine का cos x होता है, cos x की sine, like sine and cos x, these are the other form of each other. Tan x का t sec x, because these are interchangeable to each other. And cot x की cos x, cos x, these all are related to each other. So एक दूसरे की other form भी we can say that. So what's rule is if one of the exponent is odd, right? If one of the exponent is odd, then what we have to do, we have to substitute t is equal to something, t is equal to the term, t is equal to the other term, right? Then if like one of the exponent is odd, then we have to just substitute the order term as t. So this is the start point. Examples अच्छे से clear हो जाएंगी. What I'm trying to say, just follow through the rules. Rules सही चल रही है हमें. But the second rule is, so I'm saying कि, but if the exponent, uh, is even, okay, uh, if the exponent involved is in even, so what we have to use, we have to use the trigonometric identities. Okay, and if cos 2 theta is involved, so we know that uh, the cos 2 theta formula will be like cos square theta minus sin square theta. So we try to convert into these form. If the power is even, so we try to convert into this form and then proceed on. Or we can write like cos square theta is given, so we can write it as 1 plus cos 2 theta by 2. So we try to substitute into this kind of form. If somewhere power involved, like this is of the form, ये जो form है ये cos to the power mx की form है, where m is 2, where m is equal to 2, which is even. So we try to convert these even power into some something using trigonometric identities to convert into this kind, and then we have to integrate. But if the power is odd, we try to substitute the order term as t. I hope you'll all understand this what I'm saying. So let us move to some example, like how to solve or what. So let us move to some example one. Okay, so our first example of it's look like sine to the power x cube, sine qx dx. Okay, so this is similar to the sine to the power mx dx, where m is 3, which is an odd. So what we do, we just substitute the order term. And मैंने other term यहाँ पे discuss कर रखा है, sin की cos, tan की sec, and cot की cos x. So we have to just substitute. We have to introduce here and just substitute, let cos x is equal to t. So what we get, the first we have to differentiate it. So differentiation we get minus sin x dx is equal to dt. So now what we have to do, we have to just we can write it as like sin square x into sin x dx. We can write it as, so we can write this whole term as dt, right? And we can write this sin square x as 1 minus cos square x. because sine square plus cos square is equal to 1. So we can write it as 1 minus cos square x, and this whole term as written as uh, sin x dx. So now substitute. So we can write it 1 minus t square minus of dt, because sin x dx is dt. So this is our, so when we integrate this, what is it? 1 minus t square dt. Now integrate the following thing. So what we get? We get minus 1 dt and plus t square dt. So when we integrate, what we get? Minus t plus tq by 3 plus some constant. And when we put the value, what we substitute here, so what we get? We get cos cube x by 3 minus cos x plus some constant. So this is our integration of uh, sine cube x. So this is a one way to solve this problem. One way to solve this problem. There is a another way to solve this problem. मैंने तो ये बताया like कि ऐसा कर सकते हैं कि other term को t मान के solve करी जा सकती है. But is this the only way to solve this problem? So obviously not, because we can use another form like इसको ऐसे भी solve करी जा सकती है. Like we know that अगर आपने ट्रिग्नोमेट्री आइडेंटिटी पढ़ा होगा, ऑब्वियसली पढ़ा ही होगा 9th-10th में. तो साइन 3x की एक फॉर्मूला होती थी 3 sin x minus 4 sin cube x. दिस इज मेथड 2. आई एम सॉल्विंग विथ मेथड 2. तो उसमें क्या करते थे? सो 3 sin x minus 4 sin cube x. ओके, 3 sin x minus 4 sin cube x. So we have to integrate this term. So first create this term as like sin cube x is equal to sin 3x uh, minus 3 sin x by minus 4, right? So we can write it as, अगर से अच्छे से लिखा जाए तो we can write it 3 by 4 sin x minus 1 by 4 sin 3x, right? We can write this, yeah, obviously. Now what I'm trying to say, we have to integrate this. So just integrate this both. So if we integrate this, we know the integration of uh, sin x is minus cos x. So it will be minus cos x 3 by 4. And we also know that the integration of sin 3x is equal to minus of cos x. So it will be something 1 by 4 cos 3x and by 3, right? So will we get minus 3 by 4 cos x plus 1 by 12 cos 3x plus some constant. So we can write into this form also. And then we also know that the cos 3x formula. So we can transform into like cos 3x is equal to, we know the formula of cos 3x is just the inverse of sin 3x, something with just with sine. So what we can write the formula of cos 3x just with the change of sign only. Okay, so cos 3x formula will something look like 4 cos 3x, just change with sign, nothing else. So when we I do some mistake here, yeah, 4 cos cube x actually, right? 4 cos cube x minus 3 cos x. So this is the formula. So when you substitute here, you get the as result which are mentioned above. Okay, so this is the method 2. So try to solve with any method. Like यहाँ पे तो इसकी formula में पता था, we know the identity like the formula of sin cube x. But what if the sin to the power 5x, sin to the power 7x, right? So how to solve this kind of problem? So just go through the rule 1, sin mx cos nx, whatever. If m and n is odd, so just substitute the order term as t and just proceed on. So this is the method. मैंने दोनों से करके दिखाया यूजिंग आइडेंटिटीज, बट आइडेंटिटीज फॉर्मूले पते होने चाहिए ना। अगर फॉर्मूला याद नहीं है मुझे, so just try to substitute the order term as t if the power is odd. So let's move on to the next example actually. So our example 2 will something look like, this is our example 2, which is cos cube x sin 5x dx. Now their question arises. I am saying with the rule 1 is if the power is odd, then put the order term as t. और यहाँ पे साइन की अदर टर्म कॉस होती है, कॉस की अदर टर्म साइन होती है। नाउ अब टी किसे पुट करनी है, देन if both if both terms are present, if both terms are present, like other term be present हो, other term are also present. So what we have to do, we have to substitute, then at this situation we have to substitute t is equal to whose power is maximum, right? So here the power is max is sin x. So just substitute t is equal to sin x and proceed on, right? So this is and another. Okay, let me read it first. This line, okay, and make it in with so this is our important. So this is our important point. So now let's try to solve this problem. So what we have to do, just substitute t is equal to sin x. So dt is equal to cos x dx, right? When we write our integration, our integrand look like, first write the integrand. It will be cos cube x sin 5x dx, right? So first try to write it as cos square x sin 5x cos x dx. So this will form our dt. And so what do you do? We can write it as 1 minus sin square x sin to the power 5x, and this term is our in next step we can do, so cos x dx. Now do 1 minus t square t to the power 5 dt. This whole term is dt. So what we get, t to the power 5 dt minus t to the power 7 dt. So when we solve this, it will be like t to the power 6 by 6 minus t to the power 8 by 8 plus some constant. Now just substitute the whatever we put in previous step. So write it as sin 6x by 6. Let me raise this, and minus sin 8x by 8 plus some constant here. So this is our basic things that we have to proceed on. I hope you'll all understand what I'm trying to say. Okay, so now let's move on to the third problem. जितने ज़्यादा प्रॉब्लम, एक दो प्रॉब्लम से क्लियर हो जाएंगी, so that will be better for you. So let's move to the some even cases, like example third example. We have to integrate like sin square x. So we know that when sin to the power mx, where m is even, so we have to use trigonometric identities. We have to use a trigonometric identity. So what is how we can write sin square x? So we can write it as 1 minus cos 2x by 2, right? And then integrate this. So let's start on we can write it as 1 minus cos 2x by 2 dx. First take half outside the uh, integrand and just start integrating. So 1 by 2, the integration of look like x, and cos 2x integration will be like sin x, right? So sin 2x by 2, right? Plus some constant. So this is our uh, integrand. So this is our integral, right? I hope you'll all understand what I'm saying. Let's move on to the another example in uh, even one. So example 4. This is the last example. Then we move to some special cases or some more special cases. So example 4, something look like sine square x cos to the power of 4x dx. Okay. So we can write this into some arrange way. Like we can rearrange something from here. And if we look here, we can create here sine square x cos square x into cos square x. And we know that uh, sine 2x is something 2 sine x cos x. And if we square this both terms, so what we have to do, 4 here create, right? So just multiply and divide by 4. What we get? 1 by 4. This whole term, we can write it as sine 2x whole square, right? Sine squared 2x, right? And this is our cos square x, right? And there is power is even. So what we have to do, we have to just go through the identity one. No other way. We have to use trigonometric identities. We have to use the trigonometric identities, right? So what we can use here, we can write like sine 2x, sine squared 2x is equal to 1 minus cos 4x by 2. And we can write cos square x as 1 plus cos 2x by 2. And then we can multiply and then we integrate the following, right? So let's write it here. Our integral look like 1 by 4 of uh, integration of, we can write a sine square 2x as 1 minus, okay, cos 4x 1 plus cos 2x by 2 dx, right? Then what you have to do, just solve this. So 1 by 16 and multiply the both one. So what we get, 1 cos 2x minus cos 4x minus cos 4x cos 2x, right? And it will be dx. So we can write this term as 1 by 16. You also read in class 11, like first multiply and divide by 2. So what we get, 2 cos 4x, 2 cos 2x, and the cos term is only created when cos is written cos a plus b form, cos a plus cos b. So we can write cos, add this both and subtract once, cos 2x, and then integrate. So when we integrate, it will be like x plus sine 2x by 2 minus sine 4x by 4 minus 1 by 12 sine 6x minus 1 by 2. What is it? Sine 2x. So this will get cancelled, right? And so we get finally as 1 by 16 x minus sine 4x by 4 minus 1 by 12 sine 6x plus some constant. So this is our final integral. I hope you'll all understand what I'm saying. Uh, so there is a rule. Okay. So now let's move on to the rule. What if this has to be noted? So I write it with actually note. Okay. So what if negative or fractional power are involved with trigonometric function? Then what you have to do, then just try to form They just try to form f and f dash type pair with respect to sin x cos x, or tan x sec square x. Okay, so this is a noted point. So try to do it. Now let's move on to the next type. Our next type is something look like this is our type 5. So let's move to the next type. Our type 5 look like sec to the power nx tan to the power mx tan to the power mx sec to the power nx, where similarly, let me read it, where and belongs to the whole number, right? So now what I have to do, uh, let's move to the this type tan m to the power mx. So what we have to do, we know that 1 plus tan square x is equal to sec square x. So tan and sec is interconnected to each other. So what I have to do here, I have to write this tan to the power mx as tan m to the power minus 2x and tan square x, right? And then I have to write this tan square x as sec square x minus 1. And then just substitute substitute the tan to the power m minus 2h t and just proceed on. Or tan x as just t and just proceed on. Right. So I hope you'll all understand this. So let me show you by example. So example is we have to just follow through these steps. So our example is like tan cube x. So what I have to do first, I have to write tan 1x because 3 minus 2x, and then tan square x and dx. Right. And then what I have to do, like it is formed like tan x. So write it as sec square x minus 1 dx. So now it's formed tan x sec square x minus tan x dx. Right. And then we know that if this is f, so this is df. So its integration is tan square x by 2. And the integration of tan x is sec x, ln sec x. So ln mod sec x plus some constant. I hope you'll all understand what I'm saying. So let's go through it. Now let's look into one more example. So example look like example 2, take tan to the power 4x dx, right? So what you have to do, you have to just write 4 minus 2x, then tan square x dx, and then write tan square x. It will add sec square x minus 1 dx, and then do tan square x sec square x minus tan square x dx, right? So what we get, uh, if we suppose substitute tan x as t, so this is our, so this is again the f square function and this is df. So our integration is f cube by 3. So like tan cube x by 3, right? Minus, this is tan square x. We can write this function as sec square x minus 1 dx. And we know the integration of sec square x is tan x. So we can write it as tan x and then minus into minus plus 1, and integration of plus 1 is x, and put some constant here. So this is our uh, integral of following integral. I hope you'll all understand what I'm saying. Now let's move on to some of example of JEE mains kind of thing. So our first problem is, this is mostly based on JEE mains type. देखो इसमें जितने प्रॉब्लम की टाइप में बता रहा हूँ ना, लाइक तो इन्हीं टाइप की क्वेश्चन जेई मेंस जेई एडवांस में भी आती हैं। तो मोस्टली इस टॉपिक का तो ये जो आज वाली लेक्चर ये तो मोस्टली यूज इन जेई मेंस। जे एडवांस से इससे तो क्वेश्चंस नहीं आते हैं, बट समटाइम्स इसके कॉन्सेप्ट यूज हो रहे होते हैं। लाइक कैसे, इफ साइन की पावर mx है तो कहीं वो बीच में आ रहा होगा, सो यू हैव टू लाइक, अगर पावर ऑड है सो ट्राई टू सब्स्टिट्यूट लाइक cos x as t। तो वो सारी चीजें यूज हो रही होंगी। अगर इवन पावर है सो यू ट्राई टू substitute, try to use, not substitute, try to use uh, trigonometric identities. So these are things we have to follow. So now let's move on to some example actually, it's based on mainly on JEE mains. This kind of example actually comes. So how to approach, like root under tan x divided by sin x into cos x dx. So there is a simple way to approach this kind of problem is we have to just form a function and its differentiable function. So what I'm doing here is I am just multiply and divide by cos x in denominator. So what I'm saying, just multiply and divide by cos x in denominator, because देखिए tan x, root tan x is there. So you can't take tan x out of the root from it, because there is only one option left, is multiply and divide by root tan x in numerator and denominator. But उससे भी कुछ नहीं हो रहा क्योंकि root tan x अभी numerator में है. When you multiply it automatically come in denominator. So we can't do anything with this. So we just multiply and divide by cos x in denominator to convert this into tan or sec x. So when we do that, root tan x dx, and here we get tan x cos square x. When we simplify it, we get 1 by root under tan x and sec square x dx. And then substitute here, and let me write here. And then substitute here, tan x is equal to t. So we get sec square x as sec square dx as dt. So we get 1 by root over t dt, right? And when we integrate this, what we get is get the simple form. Like 1 by root 2 will be like 2 root t plus some constant. And then put here 2 root tan t plus some constant. I hope you'll all understand what I'm saying. Okay. Let's move on to the next example. With something look like, okay, so this is our code. Next example, whatever number is, example number x. Okay, so our example look like sine square x divided by cos to the power 6x dx, right? So if we look at here, what we can do, we can create tan from here. Like we can rearrange into something like sine square x by cos square x, cos to the power 4x, right? We can write it into this one. Then create tan square x sec to the power 4x dx. Then write tan square x and sec to the power 4x, we can write it into sec square x into sec square x. And then what you can do, you can tan square x, can write this sec square x 1 plus tan square x, so that we can form like f and f dash term. So sec square x dx, and now substitute tan x as t. First multiply it, so tan square x plus tan to the power 4x sec square x t. So what now do? Just substitute tan x as t. So sec square x dx as dt. So our integrand look like t square plus t to the power 4 dt. So when we integrate this, we get it t cube by 3, t to the power 5 by 5 plus some constant, right? And then just write here tan cube x by 3 plus tan to the power 5x by 5 plus some constant. Okay, so this is a way to solve this kind of problem. Now let's move on to a special, let me read it first. A special, where is my pen? Okay, let's move to the special case number 5. 5 or 6, I think it's 6. It's known as reduction formula. Okay, so this is our reduction formula. So In is equal, first I am right here and then try to prove your tan to the power nx dx. So its reduction formula is something look like In, where n is power, obviously exponent. तो इसकी रिडक्शन फॉर्मूला आती है I n minus 2 is equal to tan to the power n minus 1x by n minus 1. So ये इसकी होती है रिडक्शन फॉर्मूला. This is important. Okay, so let's try to prove it first. So proof. मैं अभी इसको पढ़ा था. If somewhere written tan to the power nx, what I have to do first? I have to write some tan n minus 2x and then tan square x, right? Then what I have to do, I have to convert those tan square x as sec square x minus 1. We can write it as sec square x minus 1 dx, right? And then write tan n minus 2x and what is it? Sec square x minus tan n minus 2 x dx, right? We can write it into this form. Now, if we substitute tan x as t, so what we get? We get sec square x dx as dt, right? So this term is dt here. So now substitute, you get t n minus 2 dt minus what we can write here, like in is our this is our in, right? Let me show you. So this is our in, right? This is our in. This is our in given. So if in is our tan to the power nx, so what is so we can write in minus 2 as tan to the power n minus 2x, right? So here written is in minus 2. When we integrate this, what we get? Raise 1 power. So it will be like t to the power n minus 1 by n minus 1 minus in minus 2 is equal to in. Right? This all is in, right? I hope you'll all understand what I'm saying. And then what I have to do, tan to the power n minus 1 by n minus 1. Okay. And then what I have to do, I have to just substitute whatever I write here. So it will be like in is equal to tan to the power n minus 1x divided by n minus 1 minus in minus 2. So when we rearrange, we get in plus, oh, let me read it. So when we rearrange, we get in plus in minus 2 is equal to 10 to the power n minus 1x by n minus 1. So this is our reduction formula proved. I hope you'll all understand what I am saying. So let's take an example which based on uh, reduction formula. Okay. So what I am taking, our example is integrate tan to the power 5x. Look, we can use this term tan 5 minus 2 and then tan square x. We can do this thing, but we have to solve this by reduction formula, right? So let us use reduction formula. First erase it. Okay. And then use the reduction formula. So when we use the reduction formula, so we know that the reduction formula is in plus in minus 2 is equal to tan to the power n minus 1x by n minus 1. So here first n is equal to 5, right? Like I5 is equal to tan to the power 5x dx. So we can write it as I5 plus I3, right? N minus 2 is equal to tan to the power 4x by 4. We can write it as now. I hope you'll understand what I'm saying. We can write this as I5 plus I3 is equal to tan to the power 4x by 4. So we can write I5 as tan to the power 4x by 4 minus I cube, right? So this is our equation 1. We have to find the value of I5, right? We have to find the value of I5, the integral of I5. So now what you do? Now I5 is related to I3. So now try to find the I3. So I3 is equal to tan cube x dx. And when we apply the reduction formula again here, so we reach to like I3 plus I1 is equal to tan square x by 2, right? So the I3 is equal to something look like tan square x by 2 minus I1. I1 is tan square x by 2 minus I1 is something look like tan x dx, right? And we know the integration of tan x dx, which is ln sec x. So now this is our equation 2. So now put the value of I3 from equation 2 to 1. So we get I5 is equal to tan to the power 4x by 4 minus I3, and we know the value of I3 is tan square x by 2 minus integration of tan x dx. Okay, so I5 value will something look like tan 4x by 4. It is actually power. Let me write clearly here. Otherwise, you all think that it is written in subscript. Okay. So here is like tan 4x, 4x, okay. Minus tan square x by 2 and plus the integration of tan x is ln mod of sec x and plus some constant. So this is our the use of reduction formula. So how we use, let's go through once again and try to understand. So this is our reduction formula is in plus in minus 2. इसको मैंने प्रूव भी कर दी, कैसे आया, which is equal to tan to the power n minus 1 by n minus 1. Let it write some clearly like n minus 1 by n minus 1. Okay. So now first we have to apply for n is equal to 5 here. So what we get? So first I applied for n is equal to 5 here. So it will be like put n is equal to 5. So there will be 5 minus 2, 3. And then 5 minus 1 is 4 by 4, right? but here I3 arises. So we have to find I3. So now let's apply the reduction formula for n is equal to 3. Let me write it clearly. Here we apply uh, reduction formula for n is equal to 5. And here we applied reduction formula for n is equal to 3. And when we applied this reduction formula for n is equal to 3, what we get? I3 plus 3 minus 2 I1, and then tan square x by 2. So we get the value of I3 as tan square x minus I1. So we have to integrate uh, the tan x, and we know the integration of tan x is, we read in actually basic formula. So the integration of tan x is sec ln sec x. So we just write ln sec x and just put in equation 1 where I3 is required, and we get the favorable result what we need actually. I hope you'll all understand. So let me recap the today's lecture. हमने क्या-क्या पढ़ा. So we read some more type here of even power and odd power written in trigonometry, like sin x, cos x, and how to apply those kind of things if the power is not uh, if the power is given in fraction, then how to solve, वो भी हमने सीख लिया. Reduction formula. So in tomorrow lecture, tomorrow is the last lecture of indefinite integration. जिसमें we go through some more special cases of trigonometric integration, and then we overall summarize the chapter, and then we end in the indefinite integration. So I'm again saying tomorrow is our last lecture of indefinite integration. So then after we started definite integration, in which कुछ नहीं करनी होती है, बस जो भी हमने यहाँ पे इंटीग्रेट करा उसमें बस लिमिट रख देनी होती है. So that will be we read from day after tomorrow lecture. Okay, thank you very much.